For the first time, leaks around Tesla Bot Gen 3 are pointing towards something many people assumed was years away: true environmental sealing, not splash resistance, not controlled lab protection, actual waterproofing designed for real-world use. Before we go any further, if you want calm, fact-based breakdowns of Tesla developments without hype or exaggeration, please subscribe my channel so you do not miss the next parts of this series. Here is why this matters. Until now, humanoid robots have been fragile by necessity. Most are built for clean floors, controlled temperatures, and predictable environments. Water, dust, humidity, and debris are enemies because exposed joints, sensors, and actuators fail quickly under those conditions. That limitation alone has kept robots out of many jobs that humans perform every day. Gen 3 appears to change that equation. According to multiple manufacturing and component leaks, Tesla has redesigned the bot's joint architecture using sealed rotary actuators and pressure-balanced housings. This means water resistance is not handled by external covers, but by internal structural design. In simple terms, the robot is built to keep moisture out rather than survive it temporarily. This is important because waterproofing is not about rain. It is about wash-down environments, industrial cleaning, food preparation areas, medical facilities, and outdoor work. If a robot cannot be rinsed, cleaned, or exposed to humidity without damage, it cannot scale into real labor roles. Leaks also suggest improved cable routing and internalized wiring paths. Older humanoid robots often failed where cables entered joints. Gen 3 reportedly routes critical connections through sealed internal channels, reducing failure points and extending operational life. Another key clue comes from surface materials. Early descriptions point to corrosion-resistant alloys and polymer skins designed to repel water while remaining flexible. This is not cosmetic. It indicates Tesla expects prolonged exposure, not brief contact. Most importantly, Tesla does not add complexity unless manufacturing data justifies it. Waterproofing increases cost and engineering difficulty. If it is included now, it means Tesla believes the bot is close to environments where failure is unacceptable. This is not about showing off a feature. It is about unlocking use cases that were previously impossible. In the next part, we will examine why Tesla waited until Gen 3 to add waterproofing and what that timing tells us about real-world deployment plans. Why Tesla waited until Gen 3 to make the bot waterproof. The most important detail about Tesla Bot Gen 3 becoming waterproof is not the feature itself. It is the timing. Tesla could have attempted environmental sealing earlier. They chose not to. That decision tells us far more than the leak alone. Waterproofing a humanoid robot is not a cosmetic upgrade. It fundamentally changes how the machine is engineered, assembled, tested, and serviced. Every joint, every actuator, every sensor interface becomes more complex. Heat dissipation becomes harder. Manufacturing tolerances tighten. Repair strategies must change. Tesla does not introduce those complications unless something bigger is at stake. Gen 1 and Gen 2 were about learning. They were platforms for collecting motion data, refining balance algorithms, improving hand dexterity, and training neural networks to interact with the physical world. Those robots were never intended for uncontrolled environments. They were prototypes designed to fail, improve, and fail again. Gen 3 is different. By the time waterproofing appears, it signals Tesla believes the core mechanics are stable enough to survive real work. A robot that can tolerate water can tolerate cleaning cycles, spills, dust, and outdoor humidity. That dramatically expands where it can operate. Think about the environments humans work in every day. Warehouses are washed down, factories use coolant sprays, commercial kitchens are cleaned nightly, hospitals disinfect floors and equipment constantly. Construction sites expose tools to rain and mud. A robot that cannot survive these conditions is not a labor replacement. It is a demo. Tesla waiting until Gen 3 suggests something critical. The bot is no longer being designed only to move correctly. It is being designed to stay operational. Leaks also suggest Tesla shifted to sealed modular subsystems. This matters because it allows failed components to be swapped without opening the entire robot. Waterproofing at scale requires serviceability, otherwise maintenance costs explode. Tesla's manufacturing philosophy always balances durability with repair efficiency. Another reason for the delay is software maturity. Waterproof hardware is useless if the robot cannot reliably navigate unpredictable environments. By Gen 3, Tesla's vision systems, occupancy networks, and motion planning models have likely reached a point where real-world deployment makes economic sense. There is also a regulatory angle. Robots operating around humans in uncontrolled environments face higher safety scrutiny. Waterproofing reduces electrical risk, improves insulation, and increases operational predictability. That helps with certification and liability concerns. In short, Tesla waited because earlier versions were not ready to justify the cost. Gen 3 appears to be the first version where durability, intelligence, and economics intersect. That intersection is where products stop being experiments and start becoming tools. In the next part, we will examine what waterproofing unlocks specifically, the jobs, industries, and daily tasks that suddenly become viable once Tesla Bot can operate without environmental limitations. What waterproofing actually unlocks for Tesla Bot Gen 3? Once Tesla Bot Gen 3 becomes waterproof, the real shift is not technical. It is economic. Water resistance removes one of the biggest hidden barriers to automation: environmental unpredictability. Most workplaces are not clean, dry, controlled labs. They are messy, wet, dusty, and inconsistent. That is exactly why automation has struggled outside tightly managed factory cells with waterproofing. Tesla Bot is no longer restricted to ideal conditions. Consider manufacturing first. Many production floors use liquid coolants, lubricants, and washdown cycles. Human workers move through these spaces without thinking about moisture exposure. A robot that cannot tolerate splashes, condensation, or routine cleaning is unusable. Long-term, Gen 3 changes that. It can remain on the floor while environments are cleaned instead of being removed or powered. Now look at logistics and warehousing. Loading docks experience rain, humidity, and temperature swings daily. Pallets arrive wet. Floors are washed. Forklift traffic throws debris. Waterproofing allows the bot to work consistently in these spaces without special handling procedures. That reduces friction for adoption. Healthcare is another major unlock. Hospitals and assisted living facilities require frequent disinfection. Floors are mopped constantly. Equipment is cleaned multiple times per day. A robot that cannot survive these routines cannot operate safely in patient environments. Waterproofing moves Tesla Bot closer to roles like material transport, room preparation, and basic support tasks without creating contamination risk. Retail and commercial cleaning are also suddenly viable. A robot that can handle wet floors can clean them. That may sound simple, but it removes millions of repetitive labor hours from the economy. Janitorial work is physically demanding, understaffed, and difficult to automate without durability, even. Outdoor adjacent work becomes possible. Covered construction areas, agricultural processing zones, and infrastructure maintenance often involve moisture exposure. Tesla Bot does not need to work in storms to benefit. It only needs to stop failing when conditions are less than perfect. This is why waterproofing matters more than speed or strength. It signals. Tesla is designing the bot for places where humans already work, not spaces redesigned for robots. There is also a psychological component. Businesses trust tools that survive abuse. A robot that can be hosed down feels industrial, not experimental. That perception accelerates adoption just as much as capability. In the next part, we will look at what waterproofing suggests about Tesla Bot's deployment timeline and whether Gen 3 is closer to commercial rollout than many people realize. What waterproofing reveals about Tesla Bot's real deployment timeline. Waterproofing is not a feature Tesla adds early. It is a feature Tesla adds right before scale. That pattern shows up across Tesla's history. Vehicles receive major durability upgrades only when the company is preparing for sustained real-world use, not limited testing. The same logic applies here. When a robot becomes waterproof, it means Tesla expects it to operate continuously without being babied. That has direct implications for timeline. Gen 3 does not look like a research platform. It looks like a pre-production candidate. Environmental sealing only makes sense when Tesla believes the remaining risks are operational, not fundamental. Balance, vision, manipulation, and autonomy must already be good enough to justify protecting the hardware long-term. In other words, Tesla would not spend money sealing joints, wiring, looms, actuators, and enclosures if the robot still fell over regularly or required constant human supervision. This suggests limited commercial deployments could happen sooner than many expect, not public consumer sales. Not millions of units, but controlled rollouts. Inside Tesla's own ecosystem, factories, warehouses, gigafactories, places where Tesla controls the environment, the tasks, and the data feedback loop, waterproofing enables something critical here: 24-hour operation. Robots that must be shut down during cleaning cycles or environmental changes kill productivity. Gen 3 appears designed to stay online. That dramatically improves utilization rates, which is the single most important economic metric for robotic labor. There is also a safety and liability signal. Waterproofing reduces electrical exposure risks, short-circuit events, and unpredictable failures. Those are prerequisites for allowing robots to work near humans at scale. Tesla likely wants regulators, insurers, and partners to see Gen 3 as stable, predictable, and industrial-grade. Another key signal is service strategy, waterproof designs. Usually pair with modular internals. That means Tesla expects bots to be repaired, not replaced. That only matters when deployment numbers grow large enough for maintenance logistics to matter. All of this points to a narrow conclusion. Gen 3 is not the robot Tesla shows off. It is the robot Tesla keeps running if you want calm, structured analysis that focuses on what Tesla's changes actually mean instead of hype. Please subscribe my channel so you do not miss the final part. In the next part, we will connect all the leaks together and explain why waterproofing may be the clearest sign yet that Tesla bot is transitioning from prototype to workforce. Why waterproofing signals the end of the prototype era. When you connect all the signals together, waterproofing stands out as more than a technical upgrade. It is a strategic line in the sand. Tesla, but Gen 3 does not look like a robot built to impress audiences or generate headlines. It looks like a robot designed to stay operational, absorb wear, and quietly deliver value over time. That is the defining difference between a prototype and a workforce tool. Prototypes are fragile by design. They are optimized for learning, iteration, and visibility. They fail often, and that failure is acceptable because the goal is progress. Workforce machines are different. They must survive boredom, repetition, abuse, and environments that are far from ideal. Waterproofing is one of the clearest signals that Tesla believes the bot has crossed that boundary. It suggests Tesla is no longer asking, can this robot work? They are asking, how long can it work before it needs service? That shift changes everything. Once durability becomes a priority, deployment logic follows. Tasks are selected not because they look impressive, but because they deliver consistent return. Environments are chosen not for safety padding, but for operational relevance. Metrics move from demonstrations to uptime, task completion rates, and cost per hour. This also reframes how Tesla likely views competition. Many humanoid robots look capable in controlled DMOS. Very few are engineered to survive daily cleaning, moisture exposure, and long operating cycles. Tesla appears to be optimizing for the unglamorous reality of labor, not the spectacle of robotics. Under the leadership approach of Elon Musk, this pattern is familiar. Products are allowed to look unfinished until the moment they are ready to scale. Then they harden rapidly. Weak points are removed. Reliability becomes non-negotiable. Gen 3 feels like that moment, not because it does everything perfectly, but because it is being prepared for the environments where humans already work. That is where robots either succeed quietly or disappear. Entirely. If Tesla bot can operate reliably in wet, dirty, unpredictable spaces, it becomes useful. And once it is useful, adoption follows faster than most people expect. That is why this leak matters. It is not about waterproof joints or sealed housings. It is about intent. Tesla is no longer experimenting with what a humanoid robot could be. They are preparing one for what it must endure. If this breakdown helped you understand what Tesla's design choices really signal beneath the headlines, please subscribe my channel so you do not miss future updates as more details emerge. Thank you for watching. I will see you in the next one.